Welcome to this lesson on Arithmetic Series. I always start this lesson with a story that's been passed down through the centuries about a young German schoolboy in the latter 1700s. The schoolmaster wanted to keep the class busy, so the students were challenged to find the sum of the first 100 positive integers. One student was able to immediately find the sum. The teacher was amazed, not just that he had the right answer, but because of how he did it. That young schoolboy was Carl Friedrich Gauss, and he became one of the most famous mathematicians in the world. Now let's look and see how he approached this problem. Here is the famous sequence, the counting numbers from 1 to 100. It is a sequence because it is an ordered list of numbers. It is an arithmetic sequence because from one term to the next, it goes up 1. There is a common difference. When you add the numbers in a sequence, it is called a series. This is an arithmetic series. Since we're adding numbers produced according to a fixed pattern, it would make sense that there would also be a pattern for finding the sum. Let's see if we can find a pattern. If I added 1 to 100, I get 101. If I add 2 to 99, I get 101. 3 plus 98 gives me 101. I think we can see our pattern. We would have 101 50 times. So 101 times 50 is 5,050. There is a simple formula for the sum of a finite arithmetic sequence. It is S sub n is equal to n over 2 times a sub 1 plus a sub n. Let's use the example above to make sure that we can easily remember this. S sub n stands for the sum of a finite arithmetic sequence. N stands for the number of terms. A sub 1 stands for the first term, and A sub n stands for the last term. Now let's plug in our numbers so that the formula makes better sense to us. S sub n, the sum of 1 to 100, is equal to 100 over 2 times the first term in our sequence is 1 plus the last term was 100. So S sub 100 is equal to 50 times 101. So S sub 100 would be 5,050. Sigma notation is used to express the sum of a series. It is called sigma notation because it involves the uppercase Greek letter sigma. This is the notation that would represent the positive integers from 1 to 100. N is the index of summation. 1 is our lower limit of summation. 100 is our upper limit of summation. And n, in front of the sigma, is our general term or our explicit formula. To find the first term in a series written in sigma notation, substitute the value of the lower limit into the expression for the general term. To find subsequent terms, substitute consecutive integers that follow the lower limit, stopping at the upper limit.